Now, how to normalize a vector? What is the idea behind normalize a vector? This is a way to look for the direction of a vector. Remember, a vector is to get the magnitude and the direction, okay, to combine together. Now, we know how to get the magnitude. Now, we need to know the direction. How important is this? If I'm here, what's the name again? Tishan. And I want to apply a force that is 40 Newton in the direction of Tishan, I need to take where I am to where is, build a vector, and normalize it, and apply this force, this into that direction, and that will give me vectors. That's the direction. If I am a moving game object, okay, I stand here, and I move with velocity 1, 0, 1, then probably in your graphic, in your code, AI probably, or physics, you might need to calculate where I'm heading, where I'm going. What is my direction again? Okay, how do you get direction up here? Is to normalize the velocity. If I apply force, boom, I want to know what is the force after you apply it. Again, take the vector force like you have, maybe define this way, and normalize it. So now how in math we normalize a vector? Yes?
What does it mean to normalize a vector?
Yeah, does it mean that calculate the direction?
Calculate the direction.
Yeah, to a point that once you do that, the vector length is 1. Okay. And if you normalize norm, means that the vector at the end of a process length will be 1. That's the term here. Normalize a vector, it means that calculate the direction of a vector, put it this way. And to make simple up here, you have a moving body, okay, in your game simulation. The body is moving, okay, like this box here is moving with this velocity. How do you calculate the direction of this box? Is to normalize this vector. Now, if a force is being applied in the game, okay, if a force is 1, 0, 1, okay, the intensity magnitude of a force is the square root of 2. Now, and the goal now is you want to calculate in which direction this force is being applied. That's very important. How do you do it? Again, is to normalize the vector. So how do you do it here? Let's assume that you have a vector. We have a vector v, or any vector a. My eraser. Yeah, I'm gonna get a new one. Oh, okay. I got a better one here. Guys, let's say we have a vector A. A is having as component A1, A2, and A3. And we calculate the length of A. A length is the square root of A1 squared plus A2 squared plus A3 squared. Now, the normalized vector of A is to divide the component of A by its length. Remember, we are dividing. Every time you want to divide, okay, some term by another term, excuse me, you have to make sure the divider is not 0. The divisor is not 0. Okay, so therefore, I'm going to write this. If the length of A is not 0 number, then the normalized vector of A is, this is how we represent it, A hat. When you see A hat, it means that it is a normalized vector, a unit vector. Okay, that is the direction of the given vector A. So A hat is A divided by its length. Or better, if you want, A is going to be this A1 divided by the length, A2 divided by the length, A3 divided by the length. So this is how I'm going to code this. If I have to run my math library, it has to be something like this. See? Let me see if I have one like this in my math library. A vector normalized math library. Go. No. This is the head file. CP. Oh, come on. I don't. I'm looking for it. If I don't have it, that's fine. It has to be if, oh, here it is. Give me a second. So this is how we normalize a vector. I'm supposed to put my set here, but that's fine. I could go. I have M here. Give me a second, guys. I will come back to what I had before. Okay. I'm dividing here. All right, guys. So where is it? So I have this my function here. So what you see here, this one is line, is what you have. Oh, my ruler. Sorry. Is this part. Guys, it's going to be the first component, square. This is A1 times A1. I say, and here is X, and then this is a Y component, that is Y times Y. And this is the Z component, that is E3 square. That is E3 times E3, but back I'm using Z. That is therefore Z times Z, and that is square SQRT. That is this formula. Once I have this, I need this condition here. I could have done this. I made it simple. I could have I have my asset here, I don't know why I comment it out, but I could have wrote this here that if M is positive, okay, then do return this. Cool. Now, now my normalized vector is, this is A hat, is the first component divided by the length. That is called, the code M. You have it. Does it make sense to you guys?
What does M stand for?
M is the magnitude, the answer for this square. And this is this one. But in the code, I call this M. You can call it anything you want to. Okay. And now this is M. That's M here, magnitude. And goes M here, M. And this represents X, Y, and Z back there. And I return it. So this is how we normalize a vector. So let's say here, apply this to the V, that's a V, and see where the box is going. So in this case, your example is this. If V is 1, 2, minus 2, then the length of V is, we have seen this, is 1 square plus 2 square plus minus 2, the whole thing square, that is 4 plus 1, that is 8 plus 1, 9. And the answer is 3. And then the normalized vector that represents the direction of this vector is going to be V divided by the length. And the length of V is 3. Bring up, it gives you 1 over 3, 2 over 3. That's 3 here. And minus 2 over 3. That is the duration. Where is going? Now, if we take the length of this vector, V hat, norm, that will give you 1. That is why we call this type of vector unit vector. Unit. Uno. I mean, the length is 1. Unity. Take norm of this. This part square is 1 over 9. This square is 4 over 9. Minus 2 over 3 square is, again, 4 over 9. Add it together, it's going to give you 9 over 9. That is 1. Okay, of course, I missed my square root, but the square of 1 is still 1. You got for me, guys? Now, let's look at this one here. If the vector here, force, vector force is 1, 0, 1, then what is the direction of application of a vector? Now, before I do this, okay, I'm going to use this, this length, okay, and multiply to the direction up here. I take the length of V, that is V norm, multiply by v hat. That will be v. The norm is 3. V hat is 1/3, 2/3, minus 2/3, and multiply the 3 inside, gives you 1, 2, minus 2, and we're back to v. A vector v is its magnitude multiplied by the direction. Now, in this case here, application, the force applied here is 101. For instance, Newton. What is the direction of the force applied? So, do we say anything? I'm going to erase this, guys. Like this. I will erase this. And my force now, my vector force is F is 101. I need the magnitude of this force is the square root of 1 square plus 0 square plus 1 square, that is the square root of 2, that is 1 plus 1. So we have the square root of 2, and this square root of 2 is not 0. So therefore, the direction of application of this force is called F hat, is F divided by its magnitude. And that is what? This is the square root of 2. And that's going to be applied inside, gives you 1 over the square root of 2, 0 over the square root of 2, and 1 over the square root of 2. Simplify is 1 over the square root of 2, 0, and 1 over the square root of 2. You can leave your answer this way, or if you want, you can branch with it. It's the same. Or if you want, it's the same as the square root of 2 over 2, but you can leave it in this way. But if you go back and leave your answer this way, that's not good. Please. Never, please, guys, do that. And leave your answer this way. That's not good. I've seen this in some math class where you guys have been, some students have been doing this. If I see that in the test you have something like this, I might probably take some points from you. But when I see something like this in your homework, I give you 0. Yeah, I'm very strict on this. Because remember, this class is the same class that when you have an interview, remember when you go outside your interview, guys? They ask you to be proficient in C++ or the programming language, and then through the math, it's linear algebra. Yep, linear algebra. And I think you got to have 3 exams before going to final exam for, I think, data structure, system programming, and linear algebra question. So you are at an interview and you have 0 over 4. The person doesn't know you, probably is afraid, and you want the job, and you're also afraid. But they give you tests. On the math test, for instance, you have 0 over 4, and you don't write this is 0, but you leave your answer this way. When you do something like this, you open a safe. It means that now you have a weak link. Look, hello, huh? That's not good. That is not good. When you have an interview, it's like you are fighting. When you fight, you protect your face. Huh? This face? And you know what I mean? Okay. Right. Okay. But when you fight and you open this way, the person goes in. Pop. And you open yourself. And you guys must call me and say, Mr. Wahine, I have somebody who wrote 0 over 4. What should I do? I say, I don't know. But don't do this. It's math, okay? Because we are going to see this. It doesn't mean that you cannot code, okay? It doesn't mean that you're not a good programmer, but it's having something that, and I mean, here you open something and they judge you. I mean, look, man, if you have something like this and you are giving an interview, what's your feeling? Say, oh man, I'm gonna go and make a kid. You're more confident. Say, oh, if I know this, if I know that 0 divided by 4 is 0. That's bad. I've seen some people doing this. This is this 0 is 0 times 1 and 0 times 1. And we simplify 0 and we have 1 over 1 is 1. That's not true. No, because this can be simplified this way, provided that the number that's being divided here is not 0. You have this condition, and some people do some bad math. We don't have that. We don't have this if condition, and just this you can simplify this one. It provided this is not 0, and that's why you have this fake math up here. Could you please, I forget if you when I lecture and nobody is to use his laptop, could you please turn the computer for me? Thank you. So that is beautiful. So we have this. Any question, guys, ladies? So, okay. So I'm going to write here an algorithm that calculates the length of a vector and also normalize a vector to show you how we write a math engine, the concept, okay, based on the lecture note. This is my lecture note up here. If I'm a student, I'm going to look at this and use this to program my two functions. One that calculates the length of a vector, and the second one that normalizes a vector. It is calculate the direction of a vector. Okay. The first one is this function, and I'm going to call this. This is 2D vector, right? I will call this vec3 normalize. I mean 2D vector normalize. It is vec3 underscore. Sorry, norm, not normalize. So this function take as input argument a vector. Am I right, guys? So therefore, the input type here is going to be of type class vector. What? 3. I assume I have a vector here, class vec3, and I have float x, comma, y, and z. Okay, guys? In my class. And so the x here is for the a1, and the y here is for a2, and the z back there is for the a3. So I pass here my vector, vec3, and I pass a here. And then I need the return argument. What is the return argument type? What is the return argument type for this function? What do you return? What do we return, guys? No. A float. Look here. It returns a float. Make sure that when you define your vectors, okay, the component here, I'm using float, no int. One example is if you do this, int a is 2, int b is 3, int c is 1, and I have int here d is b divided by b, that is b and d by a, minus c. What's the answer for this one here? If you're all int. What is b? I'll pass this in. What is b here? B value? What is b? 3. What is b? 3. What is a? 2. Minus, what is c? 1. Now, what's the answer here? Say? Nope.
1.5 minus 1 is 0.5. 3 over 1 half is 3.
You do 3 over 2, and then you subtract 1 from that.
Nope.
So right now, what we have is 3 over 1 half, so let's see.
Oh, because you don't do the subtraction until after, so you have to do all the division.
What's the answer, guys? Back there, you four? You okay? Okay. What's your answer here, guys? Ladies?
Is it 3?
No. You don't ask question. I ask and you
we're
answer.
storing them as ints, so it's not going to be, it has to be a whole number, right? It can't be a fraction.
No, do not ask the question. Answer my question. What's the answer, guys? Hurry up. No, you don't need the calculators. No, it's not 6. Look, int is 2, int b is 3, int c integer is 1, and then your d is int is this formula.
It should be undefined.
Thank you. Come. High five. Why?
Because when you do 3 divided by 2, you get 1.
Very good.
And then 1 minus 1 is 0. We can have
That is
one.
int integer division. You get 1.5, simply int, trunk it, give it 1, and you have minus 1 is undefined. Yeah, and that, boom, you're in trouble. Is that mean here? So, be careful. Integer division is evil. So if you float, then that would be what you say your probably 6 or whatever, minus 6, right? So when you watch your math library, you don't define this as a n. Just float. Okay. So what you're returning here is a float, and then we have this as what I return this formula. Okay, I'm gonna call this m is this square root and c plus plus is this RCRT of what? Backdate is a1 square. A1 square is a1 times a1, but in here my a that is a x y z. So that up here the intelligence is going to give me a drop down list of the x y z, and I pick the x because a1 is for x. So I'm going to have the a dot x star again a dot x plus a dot. Okay, I pick y start a dot y, and then a dot. I'm going to have up here is a to the square. Your a to the 4 z, therefore I'm going to have a dot z start a dot z. And I'll return now. And I'll return here my m. Voila. Done. Any question, guys? I have put this on the net formula. Now, before I start normalize, a vector is this, and I'm gonna have below here, and I'm gonna call it vec3 underscore normalize, and what we pass here, we pass what in? We pass what? The input argument type is what? What are we normalizing? Is it banana food? No. Look here. What are you normalizing? A vector. So in this vector, we call this vector A type vec3 A. And when you normalize a vector, what do you return? Say again. Look at your function. Okay. Do you normalize what? Do you normalize a vector? And what do we get as an answer?
A magnitude, which is
No.
as a float.
No. That is the formula that calculates the direction or the normalized vector of a given vector A. Okay, that A, we normalize A to get A hat.
Oh, direction.
So therefore we get what? What we get here? Argument, what you return type is a vector. You take a vector, you normalize it, and you have a vector as output. We have some example argument. So you have to know what the type of input argument and what you have outside. What you take up here in your function, you take a banana, you put a blender, squeeze through, add some milk up here, and you return what? Some milkshake. So you have to know the input argument. Your blender is a function. Okay? Modify that. Before you program it, it's a return something else. So we take a vector, and then what we have is math, we return a vector. So that is here. Here, we return a vector of this vector. Make sense now? Now, once I have this now, okay, and I go to a process up here, I made this. So if my vector here is vector A, then I'm going to need to normalize this vector A, get to normal. Let's define M here float. M is what? M is the mind of my vector A. I'm going to use this function, okay? The calculate length norm of So M is going to be vector 3 norm, and I pass in A here. And then my answer goes into M. And then to avoid a divide by 0, I check this. If M is equal to 0, if M is equal to 0, in this case, if this happens, okay, if M is 0, in math, we don't do math, okay? In math, we don't do math. If you have 0 vector, because if you do math, okay, if you compose of vector 0, 0, 0, the length is 0. So you don't go back and do math like we have, for instance, a vector U that is 0, 0, 0, and so when you ask to normalize this, look, the length will be 0. If you get U hat, you're going to have 0 over 0 and on and on. You don't do the math and math. You don't. You stop right there. But in computer programming, okay, when you build a function, it's a contract between you and the compiler. This is a contract here. You promise to pass in an entity of type class vector 3, and then you have to promise to return something. What happened if you gave me some money, $10? Okay, this is a contract, and I'm supposed to return $20. That is 2 times x. You give me $10, so thank you, and then I don't return anything. What would be your behavior? You don't like it. You break a contract up here. So what happens if this fails? You still have to return something, because the contract says you have to return something. It's not because I cannot have an output in mathematics, so you are not going to do it in programming. You know what I mean here? If you don't do that, the compiler is going to yell at you. So that's why we check this here. If the length norm of vector n is 0, then it means that that vector that we want to return is 0 vector, 0, 0, 0. So I don't have more space up here. Can I write this? I want to find something here called vector 3. That's the one I'm going to return. Vector 3, B. All right. And then here I'm going to do this. If M is 0, then Bx is B dot Y is B dot Z, that is 0 vector, is the one I'm going to return. Now, if M, I'm going to move here. If M is not 0, else, okay, in this case, since I'm returning B, let's assume this is B, okay, this is B, and B is having as component B1, B2, B3, and the B1, write this one here, my B1 would be Bx, that is, as B dot x is A1, that is A dot x d but by M. That makes sense to you guys? And the y component B2 is to this. That's going to be B2 is here by. B dot y is A dot y over M. That is the y. And B3, that is by, BZ, is A3 over this M, the code back there. This becomes A dot Z. So we have BZ. B dot Z is A dot Z divided by M. At the end, we return B, and voila. It's not the best algorithm, but if you have better on that, you can do. And this is what I'm doing above here. But there is a little problem here. Andreas, what is 1 plus 7? Very good. Okay. What is 2 plus 7? 9. Beautiful. What is, you see, it's fast and easy. What is 2 times 7? What is 2 divided by 7? Give me your answer 6 digits after with the small point. That's the float.
Yeah.
Take your time.
2 divided by 7, 1/7, so 2 divided by 7
I know it's the way, yeah.
is,
That's fine. I'll make it this easy for you. 4 times 7.
4 times 7 is 28.
4 divided by 7.
4 divided by 7?
Yes. Good, that's fine. You see, if you have asked me the same question, I will do have the same behavior.
Yeah.
You are a human being, you have a computer. This is a computer.
It's limited.
What I'm saying here, you see, when you add, it's fast. When you multiply, it's a little bit, and it take longer. When you divide, it's a beast. So if you can avoid the division, avoid it. The goal here is to make the compiler, the code to go faster. Dividing is beast. It's not, it's slow. Multiplying is, I will show you why, multiplying is expensive, so you can have a feel. And then when it comes to dividing, it's ridiculous. Okay, let's assume that we want to multiply two numbers, like a 102. Okay, so let's go here and do this. I want to blank this out. Control new. I have two numbers here. Okay, 2 times 100. 2 times 100, and the 100 times 2. Which one is faster? First, what's the answer for this one here? 200, and this one here? 200. Now, we are looking at the complexity, how fast, and which one is faster when it comes to multiply. Assuming that now, let's assume that now, our time, we do have a computer, okay, and that old computer, maybe from 14th, 15th, 16th century, multiplying is to add. Okay, multiplying is to add. So in that case here, which one here is very slow. Slow. The first one?
You have to add 2 100 times, and the other one's 102 times.
Okay, the slow one, you guys says, is this. Who said is this? Oops.
I think that's the slow one, yeah.
That's the slow one.
Yeah, I think that's a slow one. And wait. Yeah, that's a slow one. Oh, no. That's a slow one.
Oh, if it's too small.
That's a slow one. Now this is this. This is fast. And this is slow. Let's find out. I have 3 markers. 3 markers. How many markers?
1
One what?
marker,
Okay. How many markers?
2 markers,
Very good. 2 markers. How many markers?
3 markers.
Very good. 3 markers. Why not marker 3? You have 2 entities. There's one that is in the front. Okay, and after that, one comes. You have the quantifier that's in the front, the quantifier to the front, and then the quantified element. That is the quantifier, the quantifier, the quantifier, the quantifier. This means that I'm going to add 2 billion of 100, and this means that I'm going to add, I have 100 billion of $2. So this is going to be this one is going to be 100 plus 100. 2 loop, done. This one it counts is 2 plus 2 plus 2 plus 2 plus 2. Did you guys follow me, guys? The code, the algorithm is this. The algorithm is this. You have, you multiply int is int, multiply is int, int b. And then you return the int up here. I will work with integers, okay, guys? So since we assume that now multiplying is to add, let's see, if I say 2 times 5, it's the same as 5 plus 5, or 2 plus 2 plus 2 plus 2 plus 2 5 times. but I have to use the best one, okay? With less work, okay? So I'm gonna go back here and define something called sum. I'm adding sum being 0, and I'm gonna have my for loop. Remember, the for loop is branching, yet. So I'm gonna have for int that is I from 0. Oh, I can erase this. 0 to I less than whatever I plus plus. It's going up here. Okay. Then do this now. I have this empty. We are going to see what's going here. Then my sum is the old sum plus the other. So you see, you have a for loop. You don't want to have. If you have to do like 2 times 1,000, I won't do this. Like add 1,000 times, that's too much, man. I will add 1,000. Because a branch is expensive, okay? You don't want that. So I'm going to use between two numbers here, I'm going to use the minimum of the two numbers up here. So you call it minimum of A and B. And then up here you add the maximum between the two numbers involved and your multiplication. At the end you return, you return sum. That's it. So above here, if you have 2 here and 100 here, that's going to be what? The minimum between 2 and 100 is 2, and then the maximum is 100. So you have 2. There are 2 calls. But if you flip this, if you have a maximum up here, max up here, and minimum here, then you're in trouble. Then the max is 100, and the minimum is 2, so you're going to have 100 call. You guys see? You guys see what I mean here? So when I say multiply 2 times 100, use this algorithm. You're going to 2 plus 2, 4, plus 2, 6, plus 2, 8. You don't want to do that, right? You're exhausted. Now, look at this way, okay, and fail it. Now, think about how to division. If you can avoid the division, avoid it. So that's what we're doing here. I'm dividing up here, but I could have done something like this. I could have defined something right there, float, and define this as an uppercase M, and then take the inverse of M. Like I have it right there. I'm going to erase right there, erase this, okay? And the length M here, M. And we have V hat being 1/3, 2/3, minus 2/3. If one division takes 10 multiplies, then it means that we have, in this case, we have 3 divisions, that is 30 multiplication. Now, if you move here, look, this, based on the formula here, what you have here, this up here, this is the same as 1 over the length of 8, and times the side here, and that is, take the inverse of the length. Divide it, and then, dividing, you multiply it. That is, if I use this up here, my V hat will be 1 over 3 times V. And 1 over 3 is what? Is 0.333, okay, times V, that is 1, 2, minus 2. In this case here, I'm going to have first 1 division here to get this. That is, I assume, okay, in our old machine, okay, one division requires 10 multiplication. And then here to get to this, I have 1 division here, that is 10 multiplied. And then I got this, and then I multiply this. So this gave me 0.333, and it's going to be 0.666, okay, 66, and then minus 0.666. That is what? 1, 2, 3, multiply. And all you have 13 multiplication. And then above here, if you do division, you have 30. So we have removed 17 multiplication out. This will be optimized. So I'll go back there. I'll pre-divide this M. And when I get here, this one here, A dot X over M is the same as 1 over M times A dot X. Cool, guys? But this is already done. It's this guy, M. So what I do up here is the same as this M, and you are multiplying. Oops. Do you got for me, guys? So my code here. So my code here is not the most efficient. That's why I have commented this up here. I'm going back to it. I comment this out. I comment this out. And then instead of dividing, I multiply now. By M. Voilà. I optimize this. Yeah. It can be expensive when it comes to math because sometimes we are looking for speed. Okay, like in a game, in simulation, still in a simulation we need to be accurate, but still sometimes we are also looking for speed too. So if you can simplify your equation, do it. I will give one example how the math can impact your code. Okay, let's see one example. I'm gonna pull you guys. My former student homework on physics. Unfortunately, we don't have this anymore, so I keep it all the code and use it in my as one example simulation. So let's look at here some of her homework answer. Club simulation. Club. How we do? So if I gave you a homework and I have to take you guys homework home, then I don't need to have your code on release mode. No, it's to debug your code. Okay, let's go back here and bring this to 150 scale. So when we run this is the simulation up here. The wind is blowing. Let me say to press what? What should I press to move the ball? M. M to move the ball. Okay, maximum this. So I'm gonna press M to move the ball. M. The ball is now moving. The wind is blowing. My ball is moving so slow, and the wind is blowing. And you see it's slow. If I had to grade this, if I have 20 students or 25 students, that is, man, that's not gonna work. It'd be nice to have this on the GPU, okay? Why I go this way is because of every time the ball hits the cloth, okay, there is a constraint being applied between the point that define your cloth, okay? That is a line, point, and the physics is being applied between 2 points, like this up here. And there's some stretch, this deformed, and the physics bring it back to restore the initial length between 2 points. So you have this length, we calculate this one, and this one, and this one, this part, and this part. That's like for 6, but for all of them. So if you have 100 points here and 100 points here, you have 10,000 points. So that is a key because the square root here is expensive, more complicated than the division. That's ridiculous. So then, since we don't have this in the GPU, I use this on the resume mode. Okay, it's not supposed to be this, but it's to look at quick if a student gets the simulation correct. So I use this, I change from debug mode to resume mode, and then when I have this, if we compile to from some resource like a PDB, programming database, or whatever, something like this, and then it gives me the power now better. And then when I go back there and I press this, M to move the ball, and then looks a little better. And this is my curve. I can see all the point deform, and line form, and triangle form, rank collision. So It's to show you how some physics based on linear algebra, some function can affect the speed of a game. I was supposed to take this or this note on the GPU. You guys are doing my program on the CPU. But the GPU is more powerful, it's supercomputing. If we take this and make it nicer, bam, yeah, beautiful. The more I run this, and because I have so many things open right there, right here. Yeah, I had a lot of things open up here and running in the background. So it's all again physics and again calculus. You don't want to see a math, right? I'll show you math. Just a little bit, not too much. The math can be when just to show what is being covered up here. The math formula to see why it's so expensive. It's probably this, yeah. It's called a constraint-based. Position-based constraint dynamics. What is it again? Come on. These are this formula, yeah. So you can see we divide the length or this all formula up here. Yeah. Yeah, it's a very the first time you look at this one here is a turn off. Yeah. I agree with I know. It's a turn off. No. I know. It's a turn off, okay? But when I sit down and I bring this to your knowledge and go to myself, you say, oh, that's easy. Yeah. I mean, everybody says, oh, this is crazy, but, this is the only way to code this. Yeah, that's a new physics paradigm using most computer graph and simulation. Yeah. So it looks complicated, but it's not complicated because you don't have linear algebra yet. But when I go through my student, oh, it makes sense. That's easy. Oh, calculus. But we're not back there. So we understand how to simplify some function in our code, okay, to speed up on some process, the calculation. And then we have some example here. So in Python, let's go back here now. In Python, based on the frame, I have my frame here, and I define a vector v that is 1, 2, minus 2. And then if I want on the length of a vector, I am here. Okay, I use v that magnitude. That is, this function is from NumPy. Okay, and it's going to give you magnitude of my vector. And also in Python, we can use, this is a way to represent this when you are using this frame that is SymPy using physics. Okay, it's vector class. Now, if you use NumPy, I think I cut NumPy above here. Okay, if you use NumPy, we define it as arrays. That is, NP is for NumPy. NumPy is numerical Python. Okay. And we call array and it's a function, and we pass with square bracket 304. In this case here, if you use NumPy and you want to calculate length of a vector, from NumPy, short this way, see I have done the same thing with SymPy. That's too long. So we say SymPy as SI. You follow me, guys? So NumPy is NUMPY, and I name this as NP. If you have SymPy and you define it as SymPy as S, that's fine. By him, that's okay, cool, it will work. Okay. So I have this short as NP, NumPy, NP, and in NumPy, you have this linear algebra. Say LI linear algebra. Tap it, bam, and give you all the functional linear algebra. And we know that Mr. Bahena defined the length of vector norm. You don't have length, you don't have magnitude, but you see norm, and you pick norm of A. You calculate it, save it in M, and that's what I'm doing up here. The magnitude of A is M, and then you print it. Now here it says, if you are using SciPy, okay, Scient Python, okay, as SP in this case here, and then what you have here is this. This is how we define it. Is this guy called my vector B is SciPy that array, and I define my function this way. And in SciPy, you define it as an array that you had back there, and then you type here, you call from SciPy the linear algebra library. And in this library, you have a norm, and this is how we do it and get the same thing. So I kind of used with three way of represent a vector using Python, from symbol Python, SymPy, from numerical Python, NumPy, and from SciPy. Okay. This, when you have a Python, if you know Python and you know how to manipulate those vectors with linear algebra, trust me, if you're going to interview, the thing is this: the guy's going to ask you, do you know a Python math library? Yes, that's a big plus. Now, there are other tool library I don't cover up here. Is pandas for data framework, like a table, yeah, for machine learning. And Matplotlib, how to graph some 3D or 2D surfaces. You know. But they are easy. You can see my note back there. Do that. So, and then we know how to normalize a vector. One example here. If your reference frame is E, and this vector is a 1, 1, is 1, 0, is this vector here, is 1, no Y, and with 1, Z, is this vector. Got for me, guys? 1 on the x-axis, you have 1 here. No Z, no Y component, there's no Y here. It means 0 times E, that Y. And then you have 1 on the Z, that is 1 0 times Z. That is this vector. And then, in this case here, to get to normalize it, V is going to be take this vector and that's up here. And it gives me the drop down list and say, okay, normalize, like you see mathematics. And once I have this, I do SciPy that pretty print, and it print this. The square root, you can have an answer, it's going to be the square root of 2 over 2, 0, and the square root of 2 over 2, and that's this. Oops. Now, how do we get the direction of a vector? This is what we have seen by normalizing a vector. By normalizing a vector, okay? It's the same concept up here. So if a car is moving with this velocity 1, 0, 1, its speed is the square root of 2, and then where the car is going is this vector. That is 1 over square root 2, 0, and the same number on the z axis.